So gathering useful data for examining relationships. This is a one-day chapter. Okay. So in a blank studies, researchers observe or they question participants about opinions or outcomes. So those kinds of studies are called observe, probably a name related to that, right? They're called observational studies. Tell me your eating habits over the last 10 years and let's observe your health, stuff like that. Tell me your study habits and let me observe your, performance in a class. Okay, in other studies, researchers manipulate something and they measure the effect of the manipulation on some outcome of interest. So this is called an experimental study.
So if we have just a horse eat just apples for a year, what will happen?
Yeah, so I take my horses and I divide them into two groups. These horses get apples all year, and this group of horses gets pay. And we look and see what happens to the horses over time. Or I take half of you and I put you in a metabolic ward, and I put you on a Atkins diet, and take half of you and put you on a vegan diet, and I observe what happens to you. But the point is I control what you do. Well, not me personally, but somebody does.
Okay, big brother.
Okay, big brother, yes. Big sister. In a randomized experiment, people are assigned to groups randomly. So suppose I say, okay, well, half of the class is going to get online homework and half of the class is going to get written homework. We'll see which one is more effective. That'd be like a random. I'd randomly say, okay, this half gets this half gets that, something like that. Or half of you get a placebo pill and half of you get a vitamin C pill that maybe will cure colds. Okay, and one thing about experiments, so it's not always ethical. So, for example, the horses, maybe it's ethical. But a really good example is smoking. So it has never technically been proven that smoking causes lung cancer, because to establish causality, you'd have to take people, say half of you are going to smoke, half of you are not going to smoke, and then follow them over the years. Does that make sense? And it's not ethical to assign people to something where the incidence of smoking, of lung cancer, is so much higher than a different group. So that technically, smoking was said to cause lung cancer through observational studies only. It wasn't an experiment. And that was something that the smoking companies used for a long time to say, no, you don't know smoking causes lung cancer. It could be a confounding variable. But the rate of lung cancer is so much higher in the smoking group that they can pretty much say, oh yes, this is definitely the case. It's like it's either 13 to 20 times higher as the incidence is. Were you going to say something about that?
I was just going to say they did, extract lungs from the body and manually ventilate them.
Yes, but that officially wasn't an experiment, right? So like my great-grandma lived to be 98, and she was a lifelong smoker. I mean, she was one of the people for whom it just didn't give her cancer. I mean, and they exist. Some people do get cancer. A lot of people do get cancer, though, so point is not an ethical thing. Okay, so in each situation, indicate whether you think an observational study or randomized experiment would be used and explain each case. So a teacher wants to compare the GPAs of female students who are in sororities to the GPA averages of females who are not in sororities. So the question to ask yourself is, are these people assigned to groups randomly, or do they assign themselves and you just watch and see what happens? You watch and see what happens, right? So this is observational.
So it's observational, basically you don't do anything?
You don't do anything except for look and see, you observe what happened.
Or can you also, is under the category of giving a survey too? Can you give them a survey that you can observe?
Yeah, I think giving a survey would be probably mostly an observational thing. So women are not randomly assigned to be in a sorority or not. You just observe what happens to these people. What about this? A doctor wants to compare the effectiveness or efficacy of 2 allergy medications. Yeah, that you could probably make a randomized experiment, right? You could assign people to, how many groups do you think you want to do? Just 2, 1 for each drug? Probably 3. Why would you want 3 groups? A control group, yep. And that would be the placebo or the control group, group 1, and group 2.
Could that not also be observational if you just found people that?
Nope, it's only, you could be, if you want, but if your goal is to compare the efficacy, you don't want to not randomly assign drugs. Does that make sense? I think what you're gonna say is couldn't just find people who use this drug versus people who use that drug?
Mm-hmm.
You probably don't wanna do that, because there might be instances in which people in a wealthy area get this more expensive drug, people in a poor area get this less expensive drug, and that might be also introducing some biases in their environments.
Or like what kind of allergy?
Yeah, or also think about what is, this question is kind of asking, what is the most common thing that's used for stuff like this? And for this, definitely the most common thing used would be to do an actual experiment. Would you buy that? Yeah. Okay. A social psychologist wants to determine whether restaurant servers will get better tips if they introduce themselves by name to people they serve. So could you do this as a randomized experiment?
Yeah.
Yeah, you really could. You would say you probably wouldn't want to look and see, okay, did that server do this, did that server not, because the servers that do it naturally might just be more sociable people, right? Okay, so,
And it depends on who's at the table, like.
well, yeah, but they're trying to say that on average, that is still, you make more money if you introduce yourself by name, which, if you look at a large group of people, might be true. Yes, you might get a jerk who gives you no tip, okay, it's possible, but, yeah. So you could divide the servers into groups. Into groups. And have half give name, half not. And I guess with these kinds of questions, you should ask yourself, can I do this as a randomized experiment, or would that really be sort of impossible? Like, I don't think it's possible to assign someone to a sorority. I mean, you can say, I'm gonna make you be in a sorority. I would have been like, heck no, you're not. I mean, a sorority.
For the GPA as well.
And then say that again?
It wouldn't work for the GPA as well.
No, it wouldn't. Yep, you're right. Okay, this next one. A child psychologist wants to find whether there is an association between the amount of TV a 6-year-old children watch and how often they bully other kids at school. So, do you think parents would be okay with you saying, your kid watches 1 hour per day, your kid watches 2, your kid watches 3? Probably not, right? So you're probably just gonna, in this case, gonna observe, yep. And even if you were able to tell parents, hey, your kid watches 1 hour of TV per day, do you think that they would actually always do what you said? Probably not, yeah. So observational. The researcher does not assign number of hours of TV to watch. And so in this case, you couldn't say watching TV causes you to bully kids if watching more TV increased the incidence. But you could say that there was an association. Like maybe it increased it. I'm not sure. Okay. So review some vocabulary. In a study, it's thought that the blank variable may explain or cause a difference in the other variable. So explanatory. It just took me one whole semester to stop calling it the exploratory variable. I really wanted to go exploring instead of explaining. Some other books call that the independent variable. may cause a difference in the response, which other textbooks sometimes call the dependent variable. Okay, a confounding variable is a variable that is not the main concern of the study, but might be partially responsible for the observed results. Okay. So remember that a confounding variable affects the response and is related to the explanatory variable. For each of the situations, explain how the given confounding variable meets these criteria. So the response variable is math skills, and the explanatory variable is shoe size, and the confounding variable is age. So if you were to, say, like draw a scatter plot of them, and on this axis you had shoe size, and on this you had math skills, do you agree that the dots are going to kind of like, they're going to go up-ish? Do you agree with that? Okay, is it because bigger shoes cause you to be better at math? No. What's happening there?
As they're getting older, their ability to learn increases.
As they get older, they learn more stuff. And then they grow up. They learn more math, right? So that's the real thing going on. So the point here is that age is sorry, let me say this correctly. So age affects the response, right? So age affects math skills, right? And is related to shoe size. Okay. Response variable is number of missing or decayed teeth. That's sad. It's a terrible example. The explanatory variable is the amount of past exposure to lead. And the confounding variable is the number of visits to the dentist that a child has made in the past 3 years. So here on the response, we have number of missing teeth. Up here, we have lead exposure.
How
So-
would you measure the lead exposure?
I don't know.
Look at their house, look at the water in their house.
I don't know how you measure lead. I just don't know enough about, it's related to your house, but if you've moved and you couldn't look at their current house, right, you look at their past house. Some chemicals and things sort of stay in you, right? I don't know how to measure lead, but I do think, pretending that I could measure lead, do you think that these things probably would go up together? Yeah, okay. Number of visits to the dentist. Okay, so is number of visits to the dentist, so it's related to the response. Is it related to the, does that make sense? There's something else in there that's actually kind of lurking. Related to lead exposure because there's a reason. Because of poverty. Do you buy that? If you don't have much money, it's likely you live in a place where there is lead, right? Because like there's old lead paint. It's also likely you don't go to the dentist because it costs you money. Yes? Okay.
Oh,
Yes?
why is lead exposure on the y-axis instead of the x?
Did I mix them up? Response is X. I'm sorry.
Negative relationship? Like the more lead exposure, the less.
Lead exposure. I don't think so. I think if you have lower lead exposure, you're going to have fewer teeth missing.
Yeah.
Right? So I think they go up together.
Does it matter if the response variable is on the y?
No, it kind of does, and I really, really should have just like listed them together, right? So what I meant to say with this question was just that kids with more lead exposure tend to be less well off financially. And therefore go to the dentist less. But what the point of those questions really is to get you to understand that there can be confounding variables and what some examples of them are. X and Y dyslexia rules. Okay, so let's talk about how to make a good experiment. So something measures the effects of manipulating the environment of the participants in some way. That's an experiment. The participant does not have to be a person. It could be a plant. You say, come take these plants, I'm going to give them this kind of light, and these plants give them that kind of light. How you change their environment. Okay, then something the participants are randomly assigned to either a treatment group or a control group. That's a randomized experiment. It's totally possible to have more than one treatment group. As in, like we talked about, there could be placebo, drug 1, drug 2, right? But once you do that, you have to make sure that all of your groups have enough people in them. If you have too small of sample sizes, you can't make very good conclusions. Okay, a group in which no active treatment is used. That's called a control group, yep. And most of you already know this word. With drugs, it's called a placebo. Okay. Something called replication in science. This is the principle that a single experiment rarely provides sufficient evidence, and it's important to repeat the experiment again to have independent researchers verify the results. This can include a couple of things. It can include just doing your test on lots of people, or actually having somebody else go and do the exact same study again with different participants. And that's actually a bit of a problem in science today because most institutions that fund research, like the NSA or who's my husband work for? I can't remember. NASA. Anyway, National Science Foundation, or like he actually works for NASA because they funded his grant. They almost always only fund new research as opposed to replication of old research, which is also important to verify that old research that you found wasn't just like a lucky thing. Does that idea make sense? Okay. So an experiment in which either the participants or the researcher does not know which treatment they have been assigned. Kicker is one person. That's called single blind. I asked a bad question about this in the quiz because I didn't give enough information. So there's a question about this on the quiz. And you can say single blind, double blind, or can't say because, and fill in the because. I will grade that question, not harshly if at all. So it's a 1-point gimme. In some cases, neither the researcher or participant know who had which treatment. That's called double blind. Did anybody watch the TV show House?
Yep.
Yes? So there was, here's an example. There was that, the African-American doctor giving drugs to his girlfriend for the, what does she have? Do you remember? Some degenerative disease, like Huntington's? Yeah, and he wasn't supposed to know what drug she had, and she wasn't supposed to know what drug she had. That's double blind. But then he found out, and then he switched the drugs. Yep, okay, yeah. That's bad science. Don't do that. That's bad doctor. Okay, individuals are first matched on important characteristics, and then each member of a pair receives a different treatment. This is called matched pair design. And that might be important because you're trying to avoid a confounding variable. Like say you are studying memory and you have people of different ages. You don't want to have one group be all of your 30-year-olds and one group be all of your 60-year-olds. Does that make sense? You want to compare 40 to 40, 50 to 50, 60 to 60, that kind of stuff. And experimental units are first divided into homogeneous groups called blocks, and then assigned treatment. This is called block design. Okay. So suppose you want to determine whether people who want to lose weight would lose more in 3 months by dieting or exercising, and you've got 60 people who are going to participate. How would you just do a plain old randomized experiment with these people?
Just randomly separate them into two groups.
Yep, so randomly,
Would you wanna do 3 groups to actually have that control or not?
yeah, good question.
But you know that if they're not.
I think you
already-
could assume that doing nothing did effectively almost nothing to their weight. Most people's weight's actually pretty stable. Over short periods of time. And this would probably be in 3 months, your weight probably stays stable-ish, unless you're running a marathon, in which case mine goes down and goes back up afterwards when I eat many bags of potato chips. So randomly divide in, I should learn my lesson. We'll just say 2. Given a bigger group of people, you could probably also have a control. So divide into 2 groups of 30 each. One group diets, one group exercises. If you want to do this well, you can't trust people to not go buy potato chips on their own, right? Lock them up. Maybe keep everybody in like what they call a metabolic ward for that time. What people often do with studies about diet, they often provide counseling and coaching.
So there's someone else holding accountable?
Yeah. If you're gonna assign somebody exercise as a treatment, to make sure that they exercise, right? If you assign somebody a diet, you gotta make sure that they follow that particular diet, right? That's the kind of idea with those things. So isolation, counseling, or coach, depending on which group that you're in. Which is why it's hard to do studies for diets, right? Because people can't just like leave their lives behind for years and like only eat what you tell them to eat, yes? Yeah. Okay. 20 students agreed to participate in a study on colds. 10 were assigned to receive vitamin C, and the remaining 10 received a tablet that looked and tasted like vitamin C, but only contained sugar and flavoring. The students did not know whether they were taking vitamin C or not, but the investigators did. The students, were followed for 2 months to see who came down with a cold and who didn't. Explain whether each of the following terms applies to this randomized experiment. So placebo.
Yes.
Yes, there was a fake pill. Single blind.
Yes.
Yes. Participants did not know which pill they had. Double blind. No. The researchers knew. I got a cold because of you. Just kidding. Matched pairs. Did it make any mention of people being matched to each other? No, so no mention. Repeated measures means that you measured their cold incidence more than once. No. And replication, now this is probably a question that I would not choose to give or grade. I got this answer from your textbook. They said yes, and their reasoning was that the treatment was applied to more than one person.
So it was like simultaneously replicated?
Yeah. Although I really think that replication should refer to was this experimented, repeated, like from scratch again, but that's not how they're defining it. And 10 people also is not that much replication, right? But it was more than one person, so that was their definition of what it meant to be replication. I didn't say it was a good one, just that was what your book says. Okay. So 20 volunteers aged 40 to 65 years old will participate in an experiment to compare two methods of memorizing information. The age variation in the participants concerns the researchers because memorization skills decrease with age. True story? This does happen, right? I'm learning a second foreign language now, and my first foreign language was a heck of a lot easier 10 years ago. It could be the languages being different, but it also is that I am 10 years older. I think that matters. So describe how the study could be done using something called the matched pair design. So what would you do first with people? Match their ages, yep. So form pairs of participants by age. And then randomly assign one person from each pair to each, say treatment or memorization technique, we'll say. Do you get it? That's a good idea in this kind of situation? Yeah, okay. And so why it's a good idea is because this will allow you to control for age's association with memory. So this will help to control for the association between age and memory. Okay. Like in my example, it really would have been smart if I would have learned it, well, not smart, but my example isn't a great one because it could be the fact that it's not my memory that's going, even though I think it is. It's the languages' difficulty. The first one was Swedish, which is Germanic, like English is, and the second one is Russian, which is like a totally different structure and much more complicated. And I'm working, and I'm not a student, so. But I'm gonna say it's because I'm getting old. As marathon hobbles. Okay, in a blank study, the data are from the past. That is called retrospective. And I want to say good in quotes there because in observational studies are almost never very good, but sometimes it's your only option. In a something study, the researchers follow participants into the future and they record relevant events. This is called a prospective study. Okay, and in a something study, the researchers compare participants who have a particular attribute or condition compared to those who do not. That's called a case control. I think I've seen this done with twins. There was a great article in National Geographic a few years ago about epigenetics. You guys know what epigenetics is? So it's about like how you have your genes, and then epigenetics is like how they're expressed, right? If I understand that correctly. And their case control thing is they had twins. Identical twins. They had examples of twins. A twin got cancer and a twin did not. And isn't that crazy? Like identical twins, one twin had cancer, one twin did not. And they had another case that had cancer in their control but did not. And in that case, the control was really a control because they had the same genes.
Was it maybe an environmental?
That was their thing. They also had an example of like two young boys who they were both like, one was mildly autistic and one was like severely autistic. And the only difference that happened is I think one was very sick at a young age and took some drugs and because he was sick, and they think that could have led to this difference. But that was the kind of, I think it was an example of a case control. This case that had this situation and then this control that did not. It was a really, really interesting article. So if you can find it, it's quite fun to read. I have sisters who are twins too. Like my little sisters are identical twins, which just makes it a little bit more close to home. I was the odd one out. That's why I live here. A teacher wants to determine how class attendance during the term affects grades in the final exam. So if it's a prospective observational study, I follow you into the future. I'm taking attendance. Look, I'm doing this right now. So what do? I take attendance as the semester progresses. And I look at the grades at the end of the semester. I mean, I know I'm taking attendance in kind of a funny way, but do you think it's possible for me to take attendance and not somehow let you figure it out? With 64 of you, I'd have to be kind of sneaky, wouldn't I?
You have to know our
I have to know all your names and faces, which probably means that it's probably going to be pretty hard to take attendance without the students knowing that you're doing it. Does that make sense?
Or
So
you
the-
just do daily quizzes.
Oh my God, that would be so horrible to grade.
Or you could just like take a head count of how many people show up and then see if that relates to like the amount of good grades or bad grades.
Probably, but
Or you
the
could just
kicker
do
is that,
turning in the paper.
but a friend could turn it in for you too, right?
No.
But the point is that students probably know you're doing this, yes, if you do it this way? Okay. And I have definitely observed if I take attendance, people tend to come to class more often.
Especially you threaten you'll drop if you.
Well, that too, but there is a date after which I cannot drop you anymore. That date is about Halloween. Like after that date, I can't drop you, you can quit coming. That's a great way to fail.
Just to let us know.
Just to let you know, okay? If it was retrospective, so in this case, you didn't tell them ahead of time that you were gonna do this, so, and you didn't keep track ahead of time, like you didn't keep track of who was there, who was not, so you probably just ask them. Does that make sense? You say, how many classes do you think you missed? And then look at their grades. So ask students. About attendance habits and compare to final exam scores. I had an idea that I would do this at the end of the semester and try to compare the number of classes you think you missed to the number of classes you actually missed to see if there was a difference. Does that make sense? And I thought I had a hypothesis that students would tend to underestimate how much class they missed. That seemed like a logical thing. Unless you miss like one or none, then you kind of know, but once you go like above 4 or 5, it can be easy to forget. Okay. So refer to parts A and B and give one disadvantage for each method of collecting data. So for part A, I kind of already told you. So for the prospective study, the disadvantage that I came up with is that if I tell you I'm going to take attendance, you might change your behavior. Does that make sense? Which is actually not a bad thing, because I prefer that more of you passed. So if students know attendance is being taken, I'll say this may change their behavior. mean, I guess you can be like, no, you will not change my behavior, Beth. I will stop coming to class to prove you wrong. That's a bad idea, don't do that. How about for the retrospective?
They can just have absolutely no recollection of functions.
Yeah, I think relying on memory is a bad idea, right? Relying on memory is probably somewhat inaccurate. Ooh. Which of those is an easier method?
Perspective. But A.
I think B is easier. Think about it in terms of what's easier for me. Is it easier for me to take attendance all semester long or just ask you one question at the end?
But it's less accurate.
I didn't say accurate. I said which one is easier for me to do. Right, see what I'm saying? In terms of like this method would actually be an easier method to implement because taking attendance all semester long requires like actually doing it, right? As opposed to just saying, oh, what do you think you missed?
But unless you like pass out a paper.
That's what I'm saying, I could
These are
pass
just
out one
papers
paper.
Sitting there, but you'd have to ask every single individual person.
Yeah, but she still has to count them at some point.
Yeah, I have to count these up at some point, yeah, so. Okay, I would argue that the retrospective one probably is actually a little bit easier to implement. That'd be my suspicion, because it'd be one piece of paper I'd pass out as opposed to having to keep track of all these pieces of paper. That's just my thought. Okay, students whose undergraduate major was economics were followed for 10 years after graduation to study the number of different jobs they took. Explain whether each of the following terms applies to this observational study. So is it prospective?
Yeah.
Yes. Students were selected and followed. Was it retrospective? No. If that was the case, then you would have said 10 years would have gone by and you would have asked people. Does that make sense? As opposed to deciding to follow them. Case control, were they compared to anybody? No. To do this, like how you could have done this, they could have compared to random non-econ majors. Does that idea make sense?
Yeah.
They could be your controls. And in that case, you wouldn't pick a specific group, you'd pick a random sampling of all sorts of different groups. And the proposition might be that, oh, people that major in economics can stay in fewer jobs because they have good skills. Maybe. Or maybe they switch more because they have options. I don't know. Okay. I love these sections on difficulties and disasters because they have such great stories. So, confounding variables and the implication of causation in observational studies. So remember that you cannot conclude cause and effect from observational studies. It is just not possible. Cause and effect can only be included in experiments. Okay. So there was, and this is amazing, I teach this class and I go read stuff on like the New York Times and like you are concluding stuff from observational studies and I get very angry. There was that study about bacon. I like bacon, so I get angry about bacon. But it concluded that, well, eating meat, processed meat in particular, leads to an increased rate of cancer, and it was just an observational experiment. Like, so it was not actually randomized. Extending results inappropriately.
Is there someone you can email about that?
Probably. I think that the comment was made. I definitely read somebody else who wrote about this and was like, once again, they did it. And it was just kind of fun. So the data can only be used to make inferences about a larger group if the data is a representative sample. If I only ask college students about something, I cannot generalize to non-college students. And really, I mean, if I only ask college students at UAF, I can generalize to college students at UAF because you may be different than college students elsewhere, right? Okay. Now, there's another kind of variable that's kind of like a confounding variable. It's called an interacting variable. And this is a variable that affects the magnitude of the relationship between another explanatory variable and a response. And the interaction is said to be between the two explanatory variables. It's slightly different than a confounding variable, and I meant to look up like a really good example. I'm afraid I totally botched it and forgot, so I'll tell you on Monday. But here's an example of what your book gives for an interacting variable. So, does a nicotine patch increase success when trying to quit smoking? And there was a study conducted, and 46% of the participants who used the nicotine patch quit successfully, and just 20% of the control group did so. And I assume that control group was like a placebo nicotine patch type thing. And a possible interacting variable was the presence of another smoker in the home. When you broke that into two groups, there was the group where there was a smoker in the home and a group where there was not. Having no smoker in the house, that was a 58% success rate versus that 20%. And with another smoker in the house, it was just 38% versus 20. So do you see how that smoker in the house affected how large the response was in terms of success? So that's an example of an interacting variable. And it's said to be between the two explanatory variables, which would be the nicotine patch and the additional smoker. And I don't have a great explanation as to why this is different than confounding, okay? So don't ask me because I don't have one, but I will come back with one on Monday, I promise. I think I didn't send any questions asked for differences either, because it's like, they're so similar. Wikipedia didn't do a good job. I tried there. Okay. Now, there's another effect called the Hawthorne effect or experimenter effects. This phenomena occurs when participants in an experiment just respond differently than they normally would just because they're in an experiment. So this happens with things like diet studies and exercise studies. If you put somebody on exercise, they often tend to also improve their diet. And just because they're in this experiment where they're like, oh, exercise, they're exercising and they're like, oh my gosh, I'll eat healthier too. It just kind of happens naturally. So that's called the Hawthorne effect and the experimenter effect. And using the past as a source of data, so retrospective studies should be taken with a grain of salt. If you learn nothing else, learn this, okay? Just be careful about generalizing too much from stuff that came from just past data, especially when it's survey data, where you don't know for sure if that number was right. Okay, so an article in Science magazine, that's kind of like a good one, hopefully, discussed this study comparing the health of 6,000 vegetarians and a similar number of their friends. And there was a 28% lower death rate from heart attacks and a 39% lower death rate from cancer, even after the researchers accounted for differences in smoking, weight, and social class. Wow. So, but even so, is it an observational study or a randomized experiment? It is observational. And the reason is that people were observed not randomly assigned to a specific diet. Okay. On the basis of this information, can you conclude that a vegetarian diet causes lower death rates from heart attack and cancer? No. You can't assume it's cause, there is just an association. The kind of mantra that I was taught when I was in Stat 200 is correlation is not causation. it does tell you where to look, like maybe that is a cause, but then you've got to make a randomized experiment to establish that it is a cause. Give an example of potential confounding variable in the situation and tell me what it means to be a confounding variable. So they did control for smoking, weight, and social class, but are there other things that could also affect your cancer rate? Genetics, sure.
Exercise.
Yeah, I have that one. Amount of exercise.
Vegetarians are probably doing a lot of yoga, you know?
I actually, sugar consumption? I might be crazy, but vegetarians tend to be healthy all around, right? Which tends to be okay, but the ones that I know definitely also don't eat a lot of sugar either. A lot of them leave other stuff out of their diet too, like wheat, so who knows? What about vegetable consumption?
Is genetics not one?
Genetics could be one, but I don't know how to control for that. That seems like, if you have a big enough group, that variability probably should be ironed out. Does that make sense? With a huge group, I think that there's going to be lots of variability among it, so it's going to kind of even out in the averages.
6,000.
Yeah, 'cause if you
With
have-
6,000 people, right? I mean, those are pretty big groups. I don't think genetics so much. And so vegetable consumption, and I also maybe even organic food versus not. That's also a possibility, right? So are you consuming pesticides by accident or?
Well, even organic foods have pesticides, like
Yeah.
organic.
Well, I was just wondering how long they followed them for, because it says they it seems like they watched them till their deaths, because they were talking about death rates, but usually vegetarians aren't old, I don't know any old people vegetarians.
Because I only have this little paragraph, I cannot tell you.
Okay, because age might be a thing, but it's hard to tell.
Yeah, age might be a thing. But they did follow people and their friends. And I mean, I guess not all of my friends are the same age as me, but it's possible that they were friends of similar ages.
And their friends, does that imply that their friends didn't have vegetables?
What I think this meant is a similar number of their friends meant that they were trying to control for differences in geographics, probably geographic location and stuff like that. So if they look at me and a friend who's a similar age in the same town, there isn't exposure to, say, chemicals or something that probably made a difference. Yeah.
Yeah, see, when I originally read that, I saw it as like 6,000 vegetarians and then 6,000 friends.
I think that's what it is.
Who weren't
Yeah.
vegetarians.
Yeah, I think so.
But then that kind of reads that the friends who weren't vegetarians had lower death and heart attack rates. If you 6,000 vegetarians and a similar number of their friends had 20% lower death rate from heart attacks.
I think the wording is just really bad.
The wording's
Yeah.
funny.
Yeah.
Sorry, and I'm pretty sure that's the 28% lowered.
Because that's why I snickered when I first read it. It just made it seem like being a vegetarian was a terrible choice.
I know, I wish it was that. Sorry, my bias is there.
Associating vegetarian with an excellent choice.
Yeah, right.
Okay.
Or being a friend with one would be like great advantage.
Terrible. But the point is that could all of these things influence your cancer rate?
Yes.
Yeah, so all these things could influence cancer rate. I assumed, I guess I read it wrong. I probably left some words out as the problem. So, could be me. Okay, one more. A retrospective study of 517 veterans who had never smoked was done to determine whether there was an association between lung disease and exposure to workplace gases, dust, and fumes. In this study, subjects were asked whether or not they remembered being exposed to gas, dust, or fumes. That sounds terrible. A concern expressed by the investigators with the patients who have histories of Sorry. Spell check doesn't catch those things. Lung disease may be more likely to recall a history of exposure, whether accurate or not, than subjects in good health. So discuss whether each of the following is likely to be a problem in the study. Is relying on memory going to be a problem? Yes. I think it is unlikely people will remember how often they were exposed to something. Also, what I don't understand is how the heck would they be able to measure their exposure level? Yes.
Well, it could have depended on their jobs. The job that I had, I was constantly exposed to a bunch of different things.
That's true, and I do agree with that. But the question is, like, did you have like some kind of gauge or device that would tell you exactly how much there was there? And would you remember that? Because they were asked long after the fact.
And there's those people that be like, oh, it's not much, and then other people be like,
Oh, it's a lot.
so much.
Because people's
It was the same
responses
amount.
to, you know, a certain amount of, like, say, smoke or dust, or if you work welding, would be different. So that's my thing is that, but I think the fact that it says retrospective means they probably were asked after they'd left that job. And so then if you remember how long they were there, how many days a week they were there, how many hours they were there, that's a problem, right? Yes.
It says 517 veterans. Is that military veterans?
I think that's what they were looking at.
Okay, because it doesn't
Yeah.
discuss that again. It goes from veterans to then workplace.
Yeah.
things, so.
Yeah. I mean, but their workplace could be like, if their job is, it could have been if they were a soldier for their life, it could be that too, right? But they did ask these people, yes. Could there be any confounding variables?
Yeah.
Yeah. So I think the point is this is always a concern with observational studies.
Like how many of them were?
They did control for smoking. Did I say that in here someplace?
Yes.
Yeah, okay, they did control for smoking, so that's one thing. And could the Hawthorne effect be here? Now, the Hawthorne effect means you behave differently because you're in an experiment. No. There's no experiment here. Okay, so there you go.